resumption. I have good news here, which is the majority of websites that actually implement session resumption well, and only about 10% don't, either because they have this feature disabled, or for some other reason they advertise the feature but they don't actually use it. And this is a problem because if you don't have session resumption enabled, then you have to establish a full SSL handshake for every single connection to your SSL server, and which basically takes a long time and will significantly slow down the performance of your website, and it will worsen the experience, the user experience. And I'm going to back to trust anchors, and now we're going to look into which trust anchors are actually used. I figure this is a slide that most people here will be interested in. Now, it's important to make a distinction. This is not market share. So, although some of these trust anchors that I have listed here are certificate authorities that issue certificates directly to end users, some of these may not be, and because they will only work with other intermediate CAs, or also some companies have multiple trust roots, and they will appear many times in the same list. But the point of this slide is to actually look as to how many certificate authorities do we need to trust. Because as you may know, there's a discussion in the SSL community because the size of the trust base is exploding. And the issue is that there's no delegation when it comes to certificate authorities. Any CA can sign any domain on the internet. So even some obscure CA that you've never heard about and that virtually no one uses can sign the certificate for the largest website on the internet. So that sort of erodes our trust in the whole system. So we can see that only this trust anchors that I have listed on this slide are used to sign 90% of all certificates that we had. So just as a reminder, this study is about 600,000 certificates that we trusted. So after we identified those that we could trust, we continue the study only with that sample because we know those were valid and we know those results will be meaningful. So this is the interesting issue. If we have 429 issuers, but we only saw 78 trust anchors, there's a relationship, and we can now build a tree and figure out which trust anchors actually have delegated authority to generate certificates. And you can see here the graph, and you can see that by far the largest number of issuers come from one trust anchor, which is owned by Deutsche Telekom. And we have seen 169 different certificate authorities leading back to just one, to their trust anchor. And then you have a couple of others, such as CyberTrust and UTN, having 48 and 29 delegated certificate authorities from them. So the thing is, this is in the sample of 600,000 certificates we did see, and I'm guessing that Deutsche Telekom will have a far larger number of these certificate authorities, but they're probably very rarely used, and you're only going to see them once in a while. And the question is that often on many people, many of those who deal with SSL is how many trust anchors do we need? And I made that calculation, so you can see here that with having only 11 trust anchors, you can cover about 90% of the 600,000 certificates that we looked at. By having 23 trust anchors, you go to 99.1%, and by having 42, you go to 99.9%. Now, this is, of course, very subjective, and if you recall, our data set is skewed towards global domain names. So someone in Japan may have a different picture, and someone in some other country, perhaps people in different countries will have different certificate authorities that they use. So the exact number usually, so I reckoned that every one of us will need between 10 and 20 certificate authorities, but the exact number may vary depending on which site you visit. From here on, we stop looking into sort of certificate and issuers, and we look into the protocols and the quality of the connection. So, and this is where we go deeper into SSL and TLS. So the important thing about certificates is their keys, and most of these keys are using RSA, the RSA algorithm, and in fact we have found only 3 certificates that use DSA. The good news is the key size is usually good, and by far virtually all certificates will use a key size of 1024 bits, and then 2048 bits, and there's a very small number of sites that actually use any of these other numbers. So we also looked, if some of you may recall, in 2006 was a problem with the way certificates were generated on the Debian operating system, and the problem was only discovered in 2008, which basically made all those certificates weak. And we have discovered that there's only about 99 of these left among the trusted sites that we saw. So that problem is pretty much gone. Although interestingly, there are still some sites who haven't really replaced the certificates, and they are still very vulnerable, and basically SSL doesn't work for them. Looking further is the support for multiple domain names. I mentioned earlier that there isn't a way to have virtual SSL hosting. And so the next best thing is to actually make your certificate be valid for multiple domain names. And there are multiple ways to do that. One is to use a wildcard certificate, in which case you have a certificate that's valid for any number of subdomains. But there's also the alternative names field, which can contain any number of domain names, and they can also be wildcards too. This is a feature that can easily be abused, as you'll see later on. But the idea is that the wildcard certificate should only be used for those certificates that stay within the same department or the same organization, where same people control all these certificates. Because if you have 2 departments sharing the same certificate, one department can subvert the SSL connections of the other one. So you basically share the trust, which is something that not many people realize. So we looked into these certificates. Most are not, only 4.44% of the certificates are wildcard, and most of these are wildcard because the wildcard is the common name, but 1.72% also had the wildcard in the alternative names. And most will have just 0, 1, or 2 of these domain names. And there's a small number of certificates that have a ridiculously large number of alternative names. So you can see on the top of the list is one that has 252 domain names. And then there are those that have 191, 153. But the certificate that has by far the largest number is one that we didn't trust, but has 354 different domain names. So this is clearly an abuse of the system. The issue with having so many domain names in the certificate, apart from the shared trust, is that the certificate grows in size, and if you recall, increases the overall size of the handshake, and then slows down everything. Another very important thing is that only 35% of all certificates will actually valid for the domain name with and without the www prefix. And this is very important because usually we as technical people will like to say, okay, the domain name is www.example.com. However, in real life, what you get is people just typing these domain names sometimes with, sometimes without. So if you don't have a certificate that supports both variants, then your users sometimes get confused. So it's a shame that only 1/3, well, slightly over 1/3 of certificates actually support this. So if you're basically, my advice in this area would be, if you're purchasing a certificate, just go to a certificate authority that will automatically make the certificate valid for both of these. On this slide, I have a bit of bad news, and this is by far the most disappointing finding of the survey, which is that more than 1/2 of all servers still support SSL2. And it's really saddening because we've known that SSL2 is insecure for about 14 years now, and you should think that 14 years is enough for people to realize that they shouldn't really be running SSL2. And actually, the number is higher. It's actually 65%. because we also looked into, even if you have SSL2 enabled, do you support any of the SSL2 Cipher suites? Because if you don't support any of the Cipher suites, the SSL2 connection cannot be made. So there's about 12% of servers that have SSL2 enabled, although they do not have any of the Cipher suites enabled. The good news is, relatively good news, is that most servers will support SSL3 and TLS1, which are reasonably secure. Another bad news is that virtually no servers support TLS 1.1 or TLS 1.2. TLS 1.1 is a 2006 protocol, so it's been 4 years now. TLS 1.2 is a 2-year-old protocol. And there are good reasons why we have these protocols, because they correct certain problems with TLS1. In particular, TLS 1.2 is actually designed to solve the problem of the SHA hashing function being not being terribly secure, and basically needs to be phased out after 2010. And the best way to do this is to deploy TLS 1.2. So what we have here is, you can see that the protocols that are supported will depend pretty much on the protocols that are implemented by the libraries used by various platforms. And for example, OpenSSL, which is by far the most popular library, does not support TLS 1.2, and we don't know when it will. So we have the case where the security of the overall system really relies on the features supported by OpenSSL. I should also mention that in determining whether servers support SSL2, we also looked at those who will maybe accept an SSL2 connection, but only use it to deliver a user-friendly error message and refuse to actually do anything. And we didn't, so those were not classified as supporting SSL2. They were classified as not supporting SSL2. Then we looked into which ciphers, key exchange, and hash functions are used. And you can see that triple DES and RC4, as old as they may be, they still rule, and they're supported basically by virtually all servers on the internet. And then only after, so 99% of all servers support triple DES, 98% support RC4, and AES is only about on the third and the fourth place with about 68% popularity, which means that most of the internet is running on these older protocols, algorithms that are still secure. When it comes to key exchange, RSA is by far the most popular one, but we did see support for others as well. When it comes to hash functions, SHA is also very popular. And what is really worrying is we have seen almost no support for any of the SHA-2 family. And the SHA-1 family is essentially deprecated, and we really need to move on and stop supporting it in SSL servers. However, I doubt that will happen quickly, because from what we've seen so far. Cipher Strength is the next aspect we looked into, and I have good news here, which is the most servers actually support strong ciphers, and most will support 128-bit encryption, and a large number will support 256. So if you look on the chart on the right, you can see that only 9 servers did not support 128-bit encryption. But 68 supported 256. And the pie chart on the left will tell you what's the best strength. And the best strength for the largest number of servers, 68%, is 256 bits, which is pretty good. And virtually everyone supports 128. So those are good news here. Mixed results when it comes to Cipher suite support. Again, we have triple DES, and RC4 at the top of the list. And what we looked here is that there's a feature of SSL and TLS that allows servers to take responsibility and choose which Cipher suite will be negotiated. However, it was disappointing to see that only a small number, relatively small number of about 40% of servers took the opportunity to choose and select which Cipher suite will be used. The majority, about 60%, actually would use the first server